My YouTube channel Easy365 Learning, and today I will introduce you to the key email authentication techniques that we have in Office 365 such as SPF, DKIM, DMARC and ARC, and we will learn how these techniques work together to protect email communications and prevent fraud and abuse. Let's start reviewing the topics that we will cover today. So we will begin with the fundamentals of email authentication, then move on to a discussion of SPF, DKIM and DMARC in detail, exploring how they will work, their syntax and how the related records are published in the DNS host. So if we talk about the email authentication, it is also known as email validation, which is a group of standards to identify and prevent the delivery of email messages from false senders, that is also known as spoofing. This helps in protecting the integrity of email messages from senders in your domains so that recipients also feel confident that the messages from senders in your domain really came from you. The standards that it include are Sender Policy Framework, that is SPF, which defines what all email servers are authorized to send email on behalf of the domain. The second one is DKIM, that is known as Domain Key Identified Mail. It utilizes a domain to digitally sign parts of the message, ensuring the content hasn't been tampered during transit. Then we have DMARC, that stands for Domain-Based Message Authentication, Reporting and Conformance, which specifies actions for email that fail SPF or DKIM checks for the domain senders and defines where to send the DMARC reports. Last but not the least, we have ARC, that stands for Authenticated Received Chain. So it retains the original email authentication information when services modify messages in transit, enabling the destination email server to authenticate messages that would otherwise fail DMARC. It's really essential to understand that these concepts or these standards are interdependent and work together to provide the most effective protection against spoofing and phishing attempts. Now let's see what SPF is and how it works. So Sender Policy Framework, or SPF, is an email authentication technique that allows domain owners to specify which hosts are authorized to send emails on their behalf. It also helps validate mails sent from your organization to prevent spoof senders that are used in business email compromise, ransomware, and other phishing attacks. Let's now explore how it works, and then we'll take a look through syntax of the SPF record and how it's added in the DNS host or DNS manager. Now let's take a close look through this diagram that I have put here to understand SPF concept. So assume an organization that's abc.com and they have added an SPF record in the global DNS. So assume that there's an email server through which abc.com will be sending an email, and the server IP address is 10.0.0.1. Now let's consider that we have two organizations, abc.com and xyz.com, and someone from abc.com, such as Sam at abc.com, wants to send an email to someone there in xyz.com, such as Chris at xyz.com. So when Sam sends an email to Chris, there are certain attributes that are added to the email header when processed by ABC mail server. These attributes include sending IP address, from address, to address, and the return path. Upon receiving the email, the recipient email server will examine the return path, that is sam at abc.com, and at this point the recipient server knows that the email has come from abc.com. But how does the server verify that if the connecting IP address or the sending IP address belongs to the abc.com domain? To do this, the recipient server will query the public DNS of abc.com using the domain name from the from address. So the public DNS will return the SPF record details for abc.com, and the recipient server will check whether the connecting IP address or the sending IP address is included in the SPF record or not. And if the sending server's IP address is found in the SPF record, the SPF check will pass and the email will be routed to Chris's inbox. However, if the IP address is not listed in the SPF record, the SPF check will fail and the email will be marked as spam, or the recipient server will handle the email according to its spam filtering policies. So this is the basic concept of how SPF authentication works. Now let's take a look through the syntax of the SPF record and how to create one. So the basic syntax of the SPF TXT record for a custom domain in Microsoft 365 looks something like this. So it is v equals to SPF1 and then we have the valid mail services that will be sending emails on your behalf, and then we have the enforcement rule. So a typical SPF record for Office 365 domain looks something like this, that is v equals to SPF1 include : spf.protection.outlook.com-all, where v equals to SPF1 identifies a TXT record as an SPF TXT record. And the valid mail sources can be set of IP addresses for an application or a third-party email server, or domains that will be leveraged to send on behalf of your domain. And then we have the enforcement rule. So enforcement rule are of three types. The first one is -all, or we call it hard fail. So the hard fail indicates that there is only one specific server that is authorized to send emails, and its fully qualified domain name or IP address is included in the SPF record. And if the email is sent from any other server, it will be rejected. Then we have all, or we call it soft fail. So it is used when the organization is not sure of how many email servers it has, and this means that the users can send emails from any server, and not all of those servers are listed in the SPF record. It allows for more flexibility but still flags emails from unauthorized servers as suspicious. Last but not the least, we have $all. We also call it neutral, and it's meant only for testing purposes and is not used in production environment. It also indicates that the SPF record neither approves nor denies the legitimacy of the sending server. And always keep in mind that there could be only one SPF record per domain or subdomain, and multiple SPF TXT records for the same domain or subdomain causes a DNS lookup loop that might fail SPF. And always remember that there should be less than 10 DNS lookups. Actually, when the destination email system queries the SPF TXT record, it queries or scans through the IP addresses and the include statements in the record until the message source matches one of the specified sources. And if the number of DNS lookups is greater than 10, the message fails SPF with a permanent error. And the destination email system rejects the message in a non-delivery report, also known as NDR or bounce back, with messages such as the message exceeded the hop count or the message required too many lookups. In a layman language, each include statement requires at least one DNS lookup, and more lookups might be required if the include statement points to a nested resources. In other words, having less than 10 include statements doesn't guarantee less than 10 DNS lookups. Now let me show you how we can add an SPF record there in DNS host. Log into GoDaddy, that's my DNS host for the domain easy365learning.com. So I'll log into GoDaddy, and over here I'll go to the DNS tab, and from DNS I'll select the option that says DNS records. And if I scroll down, I'll find all the records that have been created for this domain. Now we need to create an SPF record here, and we don't see that record, right? Go to Office 365 Admin Center, and I go to Settings and Domain. Here I see it says possible server issues. So if I click on this and go to DNS records, it tells me that there is an error for this TXT record. That's the SPF record that we need to add there in the DNS host. So whenever you set up Office 365 So if you remember, when we add a domain to Office 365, we get two ways to add it. One is the automated way, where Microsoft 365 will automatically add these records to the DNS host, and the second one is manual method, where you need to manually add these records to the DNS host to verify and add your domain to Office 365. So here you see that this TXT record is not added to the DNS host, so let's get it added now. To add it, I'll go to the DNS host, and from here I'll select the option that says add new record. So it asks me what type of record I want to add. So I'll select this option and I'll make it TXT. Now it asks me to put the name of the record. So I'll go over here, select this, and copy this add symbol from here and paste it. Now it asks me to put the value for this. So I'll go over here and I'll copy this and paste it over here. Now the time to live, we'll select it as 1 hour, so you can see the same thing over here. And once that's done, I'll click on save. So now you can see that the DNS record has been updated successfully. We just need to wait for a couple of minutes before this record gets propagated, and I'll show you how we can verify that. To verify if the SPF record that you published has been propagated across the globe or not, you can check it through command prompt or a third-party website like MX Toolbox. Let's check it through MX Toolbox first, and after that I'll show you how we can check the same through command prompt. So I'll just go to MX Toolbox website. And I need to select the SPF record lookup, right? So I'll put my domain here. Perfect. I can see that this has been propagated across the globe. So that's good. Now let's check the same thing through command prompt. So in the command prompt, I'll put the command that says nslookup. I'll do set q equals to txt. And I'll put the domain name, that's easy365learning.com. There you go. We can see that the record has been propagated across the globe. So that was all about SPF. Now let's dive into DKIM, that is our second authentication standard. So DKIM stands for Domain Keys Identified Mail, and it's a way for senders to take responsibilities for the messages that they send. Actually, it allows the receiver to verify that the message was actually sent by the claimed sender and that it has not been altered in transit. And similar to DKIM, it is also a method that helps validate messages sent from your organization to prevent spoofed senders that are used in business email compromise, ransomware, and other phishing attacks. And if we go into more detail, here one or more private keys are generated for a domain and are used by the source email system to digitally sign important parts of outbound messages. And these message parts include the from address, the to address, subject, MIME version, and the message body. And the digital signature that we are talking about is stored in the DKIM signature header field in the message header and remains valid as long as intermediate email systems don't modify the signed parts of the message. And the signing domain is identified by the D equals value in the DKIM signature header field. And the corresponding public keys are stored in DNS records for the signing domain, and the destination email systems use D equals to value that is there in the DKIM signature header to identify the signing domain, look up through the public key in the DKIM DNS, and use the public key to verify the message signature. Now let's see how all this happens. Just for your information, to enable DKIM for a domain, we add 2 CNAME records to the public DNS, and these records serve as the public keys, allowing recipient email servers to verify whether the email content was altered during transmission. And once the recipient server verifies the signatures, DKIM passes and the email is considered authentic. So let's again assume that we have 2 organizations, abc.com and xyz.com.